Now that we have the robot assembled, let's work towards mounting the electronics. Now, this robot is not designed for any particular electronics. In fact, you could potentially be designing and making your own circuit board. Even expecting to use an Arduino on the body, well, which Arduino are we talking about here? They're all radically different shapes and sizes. The Arduino Mega, the Tiny, the Mini. And so that's why there's no specific holes cut in the plastic for any of the electronics. I'm going to mount my electronics using these locking wire ties, also known as zap straps. But you can use twist ties, string, duct tape, two-sided foam tape, whatever your heart's desire. Now, one quick note about zap straps though, because I know there are young people signed up for this course, and it's been great hearing from all of you, sharing with me the projects you're working on and stuff, and it's been a lot of fun. Now, these zap straps are locking. So once you do them up, the only way to remove them is to cut them off. And they are surprisingly tough, usually made out of nylon plastic. So when I was warned about this by my supervisor when I was teaching at the high school, it still surprised me that someone would do this. One student thought it would be real funny to quickly put one of these on the around a girl's finger, and he tightened it on jokingly, thinking it was some kind of, like Chinese finger trap. The problem is it cuts off the circulation in the finger, leading to tissue damage, and you can't get it off. You have to cut it off with side cutters or a knife, but it was cinched around her finger, and her finger was blue by the time she came to me in a panic. And I was trying to run around, find my precision side cutters, trying to cut it off. Others, I've heard of stories of students playing around with zap straps and putting it around their necks and thus choking to death, all because they were fooling around with zap straps. Don't play around with these. These are not toys. Keep them away from little children as well so they don't hurt themselves with it either, okay? So I'm going to put my Arduino on the underside of the board, run a zap strap around the circuit board and through these square holes here. But I'm also going to put my H-bridge on top, locked in place by the same zap strap. Now, you can put them the other way around if you want. There is enough clearance for that massive heatsink underneath on the H-bridge board, but these things also generate a lot of heat. So on top, this way, the convection currents set up by the heated air will cool the heatsink and go straight up and away from the robot. If it's on the bottom, the heat goes up towards the board itself and towards the Arduino, which is probably on top, etc. I'm honestly not worried about the heat. I'm just trying to take all things into consideration here. The heat sink is there for cooling. Might as well place it so it does what it does most efficiently. Furthermore, if you wish, you are certainly welcome to drill holes into the body and screw mount the boards. Just remember, this is acrylic plastic and it can be tricky to drill without breaking. If you've got the know-how and the tools, go for it. We'll actually be talking about machining different materials like plastics, metals, etc. in the 4th course on prototyping, because there is some skill and knowledge involved here. So I'm going to run the power wires from the battery pack with the positive wire cut off by the ON/OFF switch over to the power input connectors on the H-bridge board. Now, if you recall, the H-bridge board has a 5-volt regulator on it. Perfect! we can power our Arduino board with it. So we'll need to run a wire out of the negative power connection, preferably a black wire because this is ground or negative, and then a colored wire coming out of the plus 5 volt connection. However, we need to pull off a fancy little trick here. We are going to put a large capacitor across the 5 volt power connection. Most likely the capacitor is polarized, so watch the polarity, make sure the positive lead of the capacitor goes to the plus 5 volt connector and the negative lead goes to the negative connection. What I discovered was that when the H-bridge was driving these motors, the current draw is just large enough that it generates what we call brownout conditions. Now, a brownout is where the supply voltage drops lower than the expected supply voltage. In fact, you'll hear that term sometimes even related to household power. The power didn't go out, but for some reason it was like 50 volts AC instead of 120 volts. Now, in our case, the voltage coming out of the voltage regulator would drop enough that the Arduino board wouldn't actually work. The Arduino would just keep rebooting and never do anything. So to solve this problem during surges of current, I simply put a large capacitor across the 5 volt power supply, and it stores a charge during normal conditions. Then, during surges of current, it fills in and supplies more current to meet those demands, thus avoiding brownout. Now, the capacitor size isn't really important other than you want it big, so just grab the biggest one you got in your kit. In my case, I've got a 1,000 microfarad capacitor, but probably anything more than 100 microfarads will do the job, I expect. So run your 5 volt positive and negative wires down to your Arduino and plug them into your 5 volt positive and negative connections. You'll need 6 connectors from your H-bridge controls over to your Arduino. I've wired them up like such so that the enable pins are connected to pins on the Arduino that have PWM, namely pins 10 and 11. This way I can use PWM to vary the speed of the two motors. I then just hook up the general purpose pins on the Arduino to the control pins on the H-bridge, just like we did before. And now I can control both the direction and speed of the motors by simply changing the signals on the 6 control pins. So run the wires from your drive motors up to the H-bridge. And notice I've got the motor positive wires on the same side of the terminal blocks. The positives are both connected to the heatsink side of the terminal block. The negative wires are connected to the other terminal. If you messed up the wiring on one of your motors and got it backwards, now is the time to reverse the wiring of that motor. Put the negative wire on the heatsink side, put the positive wire on the opposite terminal. And there you have it. You've got your robot built, complete with onboard power and onboard computer. Talk about like high tech and sophisticated and stuff. You can now program your robot to make various moves. If you go back over the use of the H-bridge, you'll see how we controlled one of these motors before. It's the exact same thing now, only there's 2 motors. So in the next lesson, we'll crack out our infrared sensor again and use it to detect walls as the robot randomly drives around the room.